Right, good morning everyone. Today we are going to be having a little look at increasing and decreasing functions, and what that means is basically the gradient of a curve, positive or negative. When it's positive it's increasing, when it's negative it's decreasing, and we're going to use differentiation to show that. So have a quick look at these two curves and then we'll get on with it. Right, here's today's first example. Show that the function of x equals x cubed plus 24x plus 3 is increasing for all real values of x. So what that means is we've got to show that the gradient is always going to be positive. Now cubic graphs, if you remember, do something like that, don't they? Only in this case, this one must never be going down, this one must just be doing something more like that. So all we've got to do is show that it's always positive, and we do that by differentiating. So first thing to do is f dash of x, and then you might want to pause it and see if you can check you can get this right, because we should all do this by now. Multiply by the power, drop the power by 1 gives us 3x squared, and the x's, we just drop the x and we drop the number on the end. So we've got 3x squared plus 24. So what this means is if I was going to find the gradient at any point, I would substitute my value of x that I wanted to know what the gradient was and find out what I get. Now because this is a square number, I'm always going to get something positive at the very lowest. It would be 0 if x was equal to 0. But that means the gradient at 0 is going to be 24, because 0 plus 24 is 24. Now just to show that this is right, at this point it is important that you write that x squared is always bigger or equal to 0, and we can't just write that, we need to write for all real values of x, and therefore 3x squared plus 24 is always going to be bigger than 0 as well, because all we're doing is multiplying that number that's bigger by 0 and adding a bit more to it. Right, today's second example, finding the interval on which this function x cubed plus 3x squared minus 9x is decreasing. So that means where it's negative. Now the other one wasn't negative at all, although it was a cubic. So why does that happen? Well, if you're ever confused, remember you've always got your graphical calculator, have a little look. It won't necessarily solve the thing for you, but it may give you a bit more of an idea of what's going on. So if I hit draw there, and I've played around with the axes a bit so you can see what's going on, you can see that this cubic, because of the large amount of negative, the minus 9x, that has made it dip into a negative for a while. So all of this is positive, positive. At this point here we've got 0 gradient, at this point here we've got 0 gradient, in between there and there our gradient is always negative. Exactly how negative is changing, but it's always negative. And then after that it's positive and positive forever. So we're trying to find this zone, which means we've got to find the 2 points at which the gradient is 0, and then we want the bit that's in the middle. First up then, we differentiate. So have a little go, see if you can do that. And you should have 3x squared plus 2 times 3 is 6x, and then just minus 9. Now that's giving us a quadratic, and we want to know when that function is equal to 0. So if I write that out again as 3x squared plus 6x minus 9 equals 0, you may notice that 3 goes into all of these. So if we divide everything by 3, we get x squared plus 2x minus 3 is equal to 0. And then to find the two solutions to that, we can factorize, or use a quadratic formula if you want to. But we've got a positive and a negative. 3 take 1 is 2, so it's going to be plus 3 and take 1, meaning our solutions are x equals negative 3 or positive 1. And so it's going to be decreasing in between those 2 points. So we need to have an inequality where they're both or equal to between negative 3 and 1, and that has solved it for us. You could find those points on the graphical calculator as well, but it's always good to be aware of all these things. There are going to be times when you can't just use a calculator, but it's always a nice way to double check that you've got it right. Right, now we're nearly done for today. I'm going to give you one more example though, but I'd like you to have a go at it first, because today's work now for you is to, on page 271, exercise 12G, is to do all the questions on there. Questions 1 and 2, you may be tempted to think, oh yeah, there's 16 there that I could ignore those and just do the exam ones, but I'd like you to do the others, because with differentiation, it's a new skill, reasonably simple, but you will forget it if you don't really get it into your brain. And all of these examples do something slightly different, so they're well worth doing. And to get us started, I'd like you to have a little look at the first one, write that down, find the values of x for which the function of x is increasing for 3x squared plus 8x plus 2. So pause it, have a little go, and then see what I've got for you. Now the first thing I'd think to myself is, what's this graph going to look like? I could put it into the graphical calculator. To be honest, you end up spending a fair bit of time messing around with your axes, but we know that all positive quadratic graphs basically do that. And for all of this time, it's going to be a negative gradient, and for all this time it's going to be a positive. So we want the minimum point. Now there are other ways we could do that as well, aren't there? But in this case, we're going to use differentiation. We're going to find where the gradient is 0, and that will tell us the point of value of x for which all the values above it are going to give us a gradient that's increasing. So we should have differential being 6x plus 8, and then we want the gradient to be 0, so 6x plus 8 needs to equal 0. Then we're just solving this equation by taking 8 from both sides and dividing by 6, which we could say is the same as minus 4/3, and therefore, because we're going right, that's where x is negative 4/3, and we want everything that's bigger. So our final thing is to say that x is bigger than or equal to negative 4/3. Hopefully that should be the answer in the book. Okay, right, well good luck with all of that, folks. Let me know if you have any problems. Oh, and a reminder about homework, that's due in for Wednesday, I think. If you could just send me how many marks you got on last week's stuff.